So today we're doing 3.5. We've talked about how you can represent a line in slope-intercept form. We've done point-slope form, and so today we're doing what's called standard form. Standard form is AX plus BY equals C. A, B, and C will be numbers, but the X and the Y will stay X's and Y's. The way that you can tell if something is written in standard form is because the X and the Y are on the same side of the equal sign, okay? So, before we actually get into solving problems and graphing things in slope-intercept form, we need to add one definition to our vocabulary. So we talked about y-intercepts, right? Yes. So the y-intercept is the y-coordinate of a point where the graph crosses the y-axis. So on the example that we gave, the y-intercept was at 2, but if we wanted to write it as a coordinate, it would actually be at 0, 2, right? So what we are going to add today is the x-intercept on the back. So the x-intercept is the x-coordinate of a point where the graph crosses the x-axis. That should make sense. Here's a graph, and then we're going to write down the x-intercept as soon as everybody gets this written down. So in this example that I gave you, the graph crosses the x-axis at positive 3, but how would I write that as a coordinate? 3, 0. So what I want you guys to notice, when I'm finding the x-intercept, the y-coordinate was what? 3. No, listen. When I'm crossing the x-axis, what's the y-coordinate? 0. Do you think it will always be that way?
Yes.
When I am crossing the y-axis, what was my x-coordinate? 0. So to find intercepts from an equation, you plug in 0 for the opposite term. So I'm going to do one example to show you, and then we'll do one in our notes as well, okay? So I'm getting this example from the textbook. You guys don't need to pull out your textbook. We're going to do this in the notebook as well. So problem 1 asks, what are the x and y intercepts of the graph of each equation? To find x and y intercepts, I always make a T-chart to help me organize my work. So on the left side, I title it x-intercept. And on the right side, I title it y-intercept. And then I show all my work for the x-intercept on the left and all my work for the y-intercept on the right. So to find the x-intercept, that's where y is equal to 0. So I plug in 0 for y. So that's 5x minus 6 times 0 equals 60. What's 6 times 0? 0. So that's just 5x equals 60. And I divide by 5. So x equals 12. So this is the x-intercept. So to write that as a coordinate, I plugged in 0 for y, and what did I get for x? 12. So the x-intercept is at the point 12, 0. To find the y-intercept, you do the exact same thing, except you plug in 0 for x. So that's 5 times 0 minus 6y equals 60. 5 times 0 is 0, so we're just left with negative 6y equals 60. Divide both sides by negative 6. So y equals negative 10. So the coordinate of the y-intercept is 0, negative 10. Because I plugged in 0 for x, and then I got negative 10 for y. So how many points is this, guys?
2.
2 separate points. And that's why I want you to write them as coordinates, because a lot of times students get confused and they find the x and they find the y and they write it as one coordinate. But remember, you plugged something in for the other value in order to get that answer. Does that make sense? Also, all lines have an x-intercept and a y-intercept, so it doesn't make sense that you only get one thing. You see what I'm saying? You are finding both. So when I give you an equation in standard form, you can find the x-intercept and the y-intercept, plot those, and then just draw the line in between them. So that's what we're going to do in our notebooks. So let's write that down in our notes. oops, I got the wrong one. So in our notes, the AX part of the standard form, that's what you're going to use to find the x-axis, or sorry, the x-intercept. So you plug in y equals 0 to find the x-intercept. Okay, and then we're going to use the by part to find the y-intercept. So we plug in x equals 0 to find the y-intercept. Okay, so let's do the example that's part of this. I'm going to give you the equation 2x plus 3y equals 6, and I want you to graph it. So to show your work on this, I know I'm in standard form because x and y are on the exact same side of the equal sign, right? Okay, so I'm going to start by making my t-chart, x-intercept, y-intercept. To find the x-intercept, I plug in 0 for y, so that's going to be 2x plus 3 times 0 equals 6. 3 times 0 is what? 0, so 2x equals 6. And then I divide both sides by 2. So I get x equals 3. So that is the point 3, 0. And I want you to plot that right now. So 3, 0 is right here. To find the y-intercept, I do the exact same thing, except I plug in 0 for x. So that's 2 times 0 plus 3y equals 6. 2 times 0 is 0. So that's 3y equals 6. And divide both sides by 3. So y equals 2. So the point there is 0, 2. So 0, 2 is right here. 2 points is enough. So you can just go ahead and connect those. And then from here you can count the slope using rise over run. And you're done. Okay, so first example. Y equals negative 3 over 7x plus 5. I want you to take this, which is in slope-intercept form, and put it into standard form. So the thing that's stopping us from being in standard form to start is the fraction. What could I multiply by that would get rid of the denominator in my fraction? 7. So multiply both sides by 7. Okay? Watch what happens. 7 times y gives me 7y equals, on this side I have to distribute, right? Okay, negative 3 over 7 times 7. The 7's reduced. You could also multiply it to negative 21 over 7, but that's still going to give you negative 3x plus 35. So you multiply by the denominator so that they reduce. And then you need to get x to the other side by adding 3x. And that's all you have to do. So that becomes 3x plus 7y equals 35. And now you're in standard form. Okay? You'll also have questions about horizontal and vertical lines. Do the best you can, and then we can go over those on tomorrow.